Hi Gunnar, welcome back.
Hi, Adam. Thank you so much for having me again. I'm super excited.
And how was the summer in Hamburg?
How was the summer? Well, pretty good actually. So despite the idea of Hamburg always being rainy, it was pretty well. So yeah,
Okay.
enjoyed it.
Actually, wrong answer. I would expect something like, I hacked all the time. I had no idea how weather was outside.
Okay, I see. Yeah, I will do that next time.
Next time. Perfect. So the most brutal question. When was the very first commit of Debezium?
Oh wow, that's really tough for me because I did not start the project. So this happened before I joined, but I would think in 2016. It must have been in this year.
Almost. This was on November the 18th, 2015 by
2015. Wow. Okay.
Mr. Rauch.
Right. So Randall Haug, he was the founder of Debezium. So yeah, he started even back then. That's interesting. So funny fact is the Debezium Twitter handle. This is even registered earlier. So I think this is from 2014. So I was wondering how this came to be because I think in this year there was no idea about the project yet.
And the name is genius. DBs. So DBs-ium. So
Debezium, right. So the idea is to, like an element, plutonium, uranium, and so on. So there's Debezium.
Yeah, perfect. And Monsieur Rauch worked at Red Hat back then?
Right. So Randall was exactly like a long-term colleague of mine, and then unfortunately he left. But he founded the project. It got some good traction, and back in the day I was working on different Hibernate projects. I was working on invalidation, as you know, and then, when Randall left, the opportunity came up for me to take over Debezium, and I was very excited about it, so I did it.
Very cool. And you knew what Randall did at Red Hat back then? So it was like your colleague at Hibernate team, or?
No, so he was not on the Hibernate team, but he used to work on Debezium, and before that there was a project called ModeShape, and this was, I think, for the JCR spec, this content repository stuff. So it was related to that.
Exactly, this JCR, Java Content Repository. It was like a backend for CMS. Oh, this is his background. Okay, and you have idea why he started the project 4 years ago?
I think, he was exploring the idea of change data capture, and I think, it was quite quickly apparent that there are so many interesting use cases where this is a super useful tool to have in the box. And so he explored it, and then, he presented it at, internally to other colleagues, and there was lots of interest really in this very quickly. So this had a very, very good start. So I think that's how it came to be.
So I'm looking at the very first commits, and he started with my.
I've never seen that actually. That's interesting.
Yeah, it was. It is the wait a sec. It is the page, I think, 60 or 62 of the commits. So you have around 2,200 commits of Debezium.
Right.
And the very first he started to hack on Debezium core and MySQL was the fourth commit. And so I think he had something to do with MySQL, probably with JCR, and. Interesting approach, because what I did back then is I tried to install update triggers for DB, and if we had Oracle, there was like advanced queue, I think, and it was like a JMS-like system. So we stored the changes to the queue, which were replicated via JMS to or top JMS topics to all applications. So this is what we did, I think 10, 15 years ago, something, and this is a similar idea, but more under the hood, so you don't have to do anything, right? So
exactly.
So you are hooking into the bin log in MySQL, and how it's called, logical decoding thing, right? In Postgres.
That's for Postgres, right? So that's the thing. I mean, so what we generally do is we get change events out of your database, right? And then you can take those events like inserts, update, deletes, and react to those events. Usually it's propagated via Apache Kafka, but you have some options there. And right, so there's no single way we would get the change events from a database, right? So it's different. For MySQL, as you say, it's the bin log, and I think that's why Randall started with that, because this used to be one of the first open and accessible APIs for that. So there's the bin log for MySQL. For Postgres, there's this logical decoding mechanism, which is very interesting because it's very flexible and you have different options there. But then again, it's different from Mongo and SQL Server and all the connectors we have. So we have to do quite a lot of exploration and investigation. How can we get changes out of the different databases? But then for a consumer, that's the good thing. This is really happening under the hood. So they don't really have to care about, does this event come from Postgres or MySQL, because then the event representation, this is rather generic and abstract. So that's all hidden under the hood.
And can you also detect reads? So read detection, it could be interesting, for audits or something like that.
No. This is really about changes, right? So if there's a new record, an updated record, or something is deleted, we will get that. But no, if there's just like a select statement that would, the reason is this just doesn't show up in the transaction logs, right? So if you look at, let's say, to write a head log in Postgres, well, you would have no notion of selects in there.
Yeah, but I think it could be possible to plug into something else in Postgres or MySQL and, translate the events to like read events and just post it to different Kafka topic, let's say, right?
I guess you could somehow do it if there's a mechanism in the database. I wouldn't know how you would do it, but if you could hook into it, might be possible. But you also would have to, the sequence of events is very important, right? So you need to think about how you can synchronize those two streams. So I guess it wouldn't be trivial exactly.
The use case is not that, strange, because what I remember a few years ago, there was a requirement where we have to read the user principal and put it to a thread, and then in JDBC driver we read the principal, changed the connection so that in the database was obvious who does what, because otherwise the problem is if Java we have a connection pooling, and the connection pool runs with a different user, the resource user, right? So this is
absolutely
why,
yeah. This is funny you say it, because we just did a blog post on the Debezium blog which kind of is related to that. So it's related to auditing, and we do something similar. So if you look at a Kafka topic which has the Debezium change events, then it's like an audit log, right? So you got all the changes there, so you know when something happened and what's like all the versions of your data. But what you are missing is this metadata you mentioned, like, so what's the user, or maybe their client IP address or device configuration and all this kind of metadata. And so what we explored in the blog post is to have your application help out a bit with that. So similar to what you do. So in our case, we suggest, okay, this metadata gets just inserted into a separate table, which is written as part of the same transaction. And now this metadata table is keyed by the transaction ID. And then you can use stream processing, so Kafka streams or Flink or something like that, to correlate those change those topics, right? So in the actual change events, we also have the transaction ID as part of some metadata in there. And then you could use, for instance, Kafka streams to join those two topics and then to put the metadata from this separate table into the actual change events.
Yeah. In my case, it was a little bit harder because we used Hibernate back then or Eclipse Link, and it was more or less transparent. And all the database vendors, they have, I forgot the exact method, but it sounds like switch user or something. So you have to cast the JDBC connection to DB2 or Oracle connection, and then say, I'm actually Adam or Gunnar. And then the database will know that, and there is there are proprietary informations where you can fetch the data. This is what we did. But interesting. And so you mentioned already Kafka, but so it started like it is. I think Debezium is first. Let's consider what we should consider. Postgres, I think, is more popular, right? So we have Postgres, and there is like logical. How it's called logical decoding plugin.
Decoding, right? Yeah. So. Yeah, in terms of popularity, I guess MySQL and Postgres are the most commonly used or the mostly used connectors, which we have, because also they were like the first ones who were there.
Yeah, and so in case of Postgres, so you have to install or activate the logical encoder, and there is, I assume, a binary or plugin which you have installed, right?
Right, so Postgres is a little bit special. So the reason or the thing there is you need to install by one of those logical decoding plugins in the database itself. So this is something which runs in the database itself, and then this one exposes the change data from the write-ahead log. And now, so traditionally we used to have just one, which is called decoder buffs. So it's based on the protocol buffer format. So this uses this binary protocol buffer format to send the events from the database to our connector. And now the problem is in cloud environments. So let's say Amazon RDS. Typically, you cannot just install any logical decoding plugin, right? They won't let you install anything like that. You just get the empty Postgres service on RDS as it is. So we added support for two others. So the next one was which is called val to JSON. So this is using JSON, so it's a bit more verbose. But for instance, this is installed on RDS, so we can take advantage of that there. And now, just recently in the latest Debezium version, we added something. Also, we added support for something called a PG output, and this is pretty cool because this actually comes with Postgres as of version 10 and later out of the box. So you don't need to install it if you are on 10 or later. And now that as we support that, this gets quite a bit easier because you don't have to install anything in the database.
Okay, so the PG output is a binary which comes already with Postgres.
Exactly.
Okay.
Exactly.
And then you have to run it in a process. Let's say in a Docker container, you have to start it as well, and then it is activated.
You mean the logical decoding plugin?
No, the PG output.
Yeah, I mean, so this really runs in the process context of the database itself. So okay. If you start Postgres, this one will be running.
Okay, and then your Debezium plugs into what in Postgres? So what you are doing exactly?
So what we are doing is we create what's called a replication connection in case of Postgres, and now this one really creates a physical connection to the database, and then PG output or whatever logical decoding plugin you have, it pushes the events over this connection. So we subscribe to that, and then whenever there's like a new event, we will be invoked, and we can deal with it, convert it, send it to Kafka, and so on.
So you are actually using the same channel what you would usually use in master-slave replication, something like this, right?
Exactly. Right. Exactly.
So it means you only need the logical decoding for the actual decoding of the binary data from the database. Otherwise, you wouldn't understand what's going on through.
Exactly right. So this is really this deals essentially with the formatting of the events. So you could say so. The decoder buffs. This is using protocol buffer, so it's very efficient. The PG output, I think it's also binary based internally, no, actually it's not binary, but it's an efficient format, let's say. And then val to JSON, well, that's JSON, right? And so we have those different representations. We need to interpret them, and then we create the Kafka event.
But in theory, you could write something in Java, so you could connect to the replication part, receive all the events, and understand them and convert them to whatever you like. It would be also technically possible, right?
You mean you could somehow read the actual transaction log format yourself? Is that what you're saying?
No, you could, as my understanding is in Postgres, you are opening the replication channel. So, and then you will receive some kind of binary stuff which you don't understand. So you could actually connect from Java via plain sockets, receive the stuff, and then try to write a Java converter to convert that to JSON. This would be also
I guess you could, right? Yeah.
Just for from the high level architecture. So what it means is actually, in case of Postgres, and I think is MySQL similar to this? You also use the replication channel.
So what we use a library there, which is just the Debezium log client library, and this establishes the connection for us. Mm-hmm. So yeah, it's semantically it's the same, but we really we go to this library and then we get an eventing API from that, so it's a bit easier to use, I guess.
So the whole flow would be we do insert update and then commit, and then the commit state, the database will flush the memory to a kind of persistent lock or store, and all the databases then will call their own infrastructure because they would like to replicate, and I would even assume they're calling that before commit happens because you would like to to push the data out and commit at the same time. So almost like a two-phase commit, I would say. Almost, it's not two-phase commit with one resource. And you could properly set up that, right? Because you could specify whether the commit has to wait until the data is replicated or not. This is the general Postgres setup, I would assume.
Right. I mean, so I have to be honest, I'm not exactly sure about that detail, but usually the semantics fast is we just get to see committed transactions. So if something is rolled back, we don't get to see it. This can depend a little bit. So for instance, in Oracle, there's a way where we would also see non-committed events, but and also in MySQL it can sometimes happen, but usually, I mean, we just care about what has been committed, right? That's the interesting stuff for us.
Yeah. So, and so what it means is you don't have to implement a lot of binary stuff. So your work is mainly in Java, right?
Absolutely, right. So this is really 99% in Java. The one exception is this decoder buffs plugin, which I mentioned for Postgres, because this is written in C. Well, it needs to run in Postgres, and that's linked into that. So, but that's the one exception. Otherwise, all we do is really in Java.
Mm-hmm. And this was written by you, or?
The decoder buffs? Yeah. No, actually, this was written by another person from the open source community, and they had that on GitHub. And at some point, we created a fork of it because we needed some features, and this upstream one wasn't maintained anymore. And I think by now it's like officially archived on GitHub, and they even point to the Debezium fork as the one which is the active version of that one.
Okay. So now, in case of Postgres, so we open the channel. The PG output is responsible for formatting, or you had said val to JSON for converting the binary internal data to JSON. And what is the default formatting of PG output? Also JSON?
No, it's a specific protocol with you can read it up on the Postgres page, on the Postgres documentation. So it's like you see, okay, now this is 1 byte with the event type. So is it an event, an update, or a delete or something? Then the next n bytes represent the table name and this kind of structure.
So you open. So the first thing which happens in Debezium is you open a client Java socket, connect to the thing, receive the PG output format. Then try to format it in something, I would say, intermediary format, which is understandable by Debezium internally, to be able to push it to different formats like JSON, CSV, or whatever, I would assume, right?
Right. So, going one step back, so we don't really work at the socket level. So we really use the Postgres connection API, or maybe even just the JDBC connection API to establish a JDBC kind of connection. Then, in case of Postgres, it's a bit Postgres specific, but that's the level of interaction. But yes, then, so once we get the event, so let's say in PG output, we do this interpretation. Then we create an internal structure of the events, and then we create what's called the Kafka Connect record. So the idea there is Apache Kafka itself, that's the messaging broker, right? So this holds the topics and so on. And then there's this side project, or let's say another project of the Kafka umbrella, which is called Kafka Connect. And Kafka Connect is a runtime and also a framework for developing and running such connectors. So you have source connectors and sink connectors. So source connectors get data from somewhere into Apache Kafka. So that's what Debezium does. And then there's sink connectors, which take the data from Kafka and write it to another database or Elasticsearch or a data warehouse and so on. And now for us, what we have to do is we create this Kafka Connect source record in our case, and that's like a semantic description of the data, right? So you have this actual struct, and this can be like a nested structure and so on. So this describes what's the old version of the record, what's the new version of the record, and then some metadata like the timestamp and so on. Mm-hmm. And then there's also a schema associated with that. So this describes, those fields in the struct, they are of those types and so on, and they are optional or not optional. And then there's this notion of converters in Kafka Connect. So they take this semantical source record structure and convert it into something which then is transported to Kafka and which is stored in the topic, because Kafka itself, all the data is just binary data, right? So byte arrays. So you have different converters which are there provided out of the box. So for JSON or for using Avro as a binary representation. Some people in the Debezium community, they, for instance, use, again, Google protocol buffers at this place. So this is, again, a pluggable aspect of Kafka Connect. Really.
But these are the exactly the same converters you would use in Kafka, having producers and consumers. So this is what you are, these converters, right?
It's not exactly that, because I think if you use the Kafka regular consumer producer, I think there's called serializers. But yeah, it's pretty much the same thing and it works at the same semantics. But the converter API, this is a little bit specific to Kafka Connect.
Oh, a Kafka Connect specific, okay? Because usually you have the SERTs if you have the
exactly,
Kafka streets,
exactly right.
Serializer, and there are low-level converters in the producer. So, but I think
exactly. So it's like the same thing semantically, right?
Okay.
I mean, the one thing is those converters we use, they deal with the source record or the sync record types in their API definitions, but then the same thing would happen.
Okay. So now technically, what it means is Kafka Connector comes with own server, service, or runtime, which runs in different process to anything else. So it just boots, and this is like Kafka infrastructure. And this starts your JDBC Postgres driver in this case. The Postgres driver with, not Postgres driver, a small app with the Postgres driver. And I think in Kafka
Debezium Connector.
Yeah, Debezium Connector. In the Kafka Connect works like you have to put a jar, and which is recognized by Kafka Connector and started, right? It's like more or less plugin architecture. So
yes, exactly.
Yeah.
So you can, so it has two different modes. So there's the standalone mode and then the clustered mode. So this can again be clustered, which comes in handy if you think about failover and this kind of stuff. And then, there's a plugin concept there. So essentially there's a plugin path, and you put the connector archives into this plugin path. We need to have our Debezium connector jars, but then also, let's say, the Postgres driver and maybe some other dependencies. So this all is part of an archive, which is our deliverable. This goes into the plugin path. Then Kafka Connect will pick it up from there. And then the next thing you need to do is you need to actually instantiate an instance of the connector, right? So there you say, okay, now I would like to have an instance of the Debezium Postgres connector. I would like to point it to this particular database using those credentials. And maybe I'm just interested in a subset of the table, so you can exclude or include the tables, or maybe even just columns. So you configure this particular connector, and then, Kafka Connect will instantiate it and run it for you.
But this connector configuration is connector specific, not Debezium specific, right?
So the way it works is Kafka Connect has a REST API, and you essentially you post a JSON request with your configuration. And there's some parts which are common to all the connectors. Let's say there's you got to give the name of the connector type, so that's a fully qualified Java class name. And then, the actual configuration, this of course is specific, right? So, we try to have this unified across the different Debezium connectors we have. So let's say the username property, that's always the same, no matter which connector from Debezium you use. But then there might be some other options which are specific to Postgres. So coming back to this logical decoding plugin, there would be an option for the Postgres Debezium connector, which allows you to say, okay, I would like to use PG output, bound to JSON, or whatever.
Okay. So what it means, if I would run in embedded mode, I would just start your connector directly without the...
Right. So embedded mode, exactly. That's an interesting thing. So that's an alternative. So in a way, what we do there is we essentially do what otherwise Kafka Connect would be doing. So we take the connector, we run it, and then this allows you to run this within your own application. So you use really the dependencies, the Debezium dependencies as dependencies for your project, the jars as dependencies for your project. And then, we just will invoke a registered callback method for you. and then you can essentially do whatever you would like to do with the change event. So it's not bound to Kafka in this case. So I know people use this for all kinds of scenarios. So either to send just to other brokers like Kinesis, let's say, or Amazon Kinesis, or Nuts, all this kind of things. So we even have demos for that on our GitHub example repo, so you can see that. But then you also could use this, for instance, and this might be interesting to you actually, to just listen to the events in your own application, and for instance, to invalidate a cache. So let's say you work with JPA and Hibernate, and you have the second level cache there. Now, what could happen is if there's some data change which is bypassing the application, so let's say you do some kind of data patch right in the database, well, the second level cache entry for that also must be invalidated, right? Otherwise, your application would continue to read stale data from the cache. So this is an interesting use case for the embedded mode, because then you could listen to the change events, and then you see, okay, this is an event which changes a specific record, so now I go and invalidate this from the second level cache of my application.
Okay, so I could actually wrap it like a CDI bean and boot it from there, and then give you, for instance, a callback and convert the Kafka event into CDI event, and then I would have a nice way. So I get the event distribution inside my app with the changes of my database.
Exactly. So that's one of the use cases. I think there's more for that, but I think that's a very interesting use case for that. We have a demo for that on a blog, which maybe we can add to the show notes so people can see how this exactly works. I mean, there's one tricky thing there. So your own application, it also writes to the database, right? So this also will trigger change events. And of course, now you must not invalidate the second level cache if this is a change which your own application did, right? Because, well, in this case, Hibernate would have taken care of the cache update. So you need to tell your own transactions apart from external transactions, which you can do if you essentially keep track of the transactions you have issued. And this all is shown in the blog post.
So in one of my current projects, what we are doing, we have a JavaScript client with web components and regular, actually Quarkus or a Quarkus backend.
Oh, wow. Awesome. Cool.
Yeah, it was started with Java, and we migrated in 3 hours to Quarkus. Works great. But because of the client requirements, it's a little bit strange. Whatever we do in the client, the changes have to be replicated to all other clients. So what we actually do is we have one-way REST calls, and the back channel are WebSockets, and always WebSockets to all clients. So what it basically means, I'm changing the state in my own app, and the notification that something changed to me and to all others comes through WebSockets, like a little bit CQRS, right? So what I could actually do here is okay, the back channel is a complete different microservice. It just listens, to let's say the database changes, and then it converts them to WebSockets. Period. So this would be this would be simplify my current, for instance, project. This would be the concrete use case I could use. I would just replicate all events regardless whether are my events or not. It would
Yeah, we played a bit with WebSockets too. So there's also, I think, a demo around that which shows how you can propagate the change events to WebSockets or via WebSockets to all clients, or let's say GraphQL subscriptions, right? That's in a similar ballpark. So this is really opening up lots of possibilities.
And now a heretical question. So why Debezium and why I shouldn't use application and scheduler and just schedule every second my table?
Okay, that's a good question. So there's different reasons why I think the transaction log-based CDC change data capture is advantageous. So one of them is, if you do this polling you describe, you're just never sure you would actually see all the changes, right? So, I mean, let's say you have 2 updates in a close time, and now you do your polling. It just might happen those updates happen between 2 of your polling attempts, so you would just see the latest state, right? So you would miss out this one or any previous updates. So this could or could not be a problem depending on your use case. Then, well, you need some way to identify which records have changed since you polled for the last time, right? So you need to have some sort of marker column, some timestamp or something. So there's this impact on your model, which you don't have if you do the log-based CDC. you wouldn't get any deletes, right? So if something gets deleted from a table, well, if you do polling, there's just no way you would see it. So that's the thing. And you also get deletes from the logs because they are appended as an event to the transaction log. And finally, I mean, there's this conflict there. You have you want to do this polling loop you describe pretty often, so to minimize the chance you lose changes or you miss changes, right? But then this also creates like a substantial load on the database at some point. So you repeatedly run this query, and maybe the DBA at some point says, please don't do that. Whereas you don't have this kind of performance overhead with the log-based approach.
Yeah. And it becomes extremely complicated because you have the same problem so back then we tried to replicate the state between clients and the application server, let's say Hibernate cache. And the removes are the problem. And even something like do insert, remove, insert, right? And if I insert with the same data, which can happen, and remove was happen between, I will poll in interval which is larger than the set of the transactions, then I will miss everything. So I wouldn't see any changes in database. Also, something happened, and this is actually a no-go for audits, right? Because if I have so this is I hear the polling stuff sometimes, but actually polling is way harder than previously assumed. And with your connector, it's a clean solution because you see every transaction actually.
Exactly right. So I mean, sometimes people start with that and then they figure, okay, it's not enough. I mean, the one thing is, well, this would work with any kind of JDBC database, really, right? Whereas in case of Debezium, well, if we need to have a connector for each of them, so that's the challenge there. But we try to expand our footprint there. So there will be, for instance, DB2. So actually, IBM guys are working on that right now. So we hope really to have all the substantial or relevant databases covered.
Oracle is also on the horizon, right?
Yes, so Horizon just describes it well. So this is a bit tricky because there's no API which is free to use and which would allow us to do what we need. So we currently have support for Oracle, but we use a library which is called Xstream, and it's not part of the Oracle database license itself, so you need to license that separately, and it's costly. So some people use it, but that's a problem. And now, well, someone from the community is looking into alternatives. So there's, different ways one could probably do it, and they're exploring this and they're working on it. And we see how it goes. I hope they come up with something.
What could work is because so just a rough idea is all the backup solutions, right? Because the backup solutions have to read the logs and translate into something else. So I have no idea whether there is an open source backup solution for Oracle. But this could work. Right?
Yeah, we have been looking into different ways. It's so far nothing really came up. I mean, there's this one package which is called Logminer, and which essentially is a package which comes with Oracle, which gives you access to the logs. So that's what those folks from the community are currently exploring. I hope it works out.
And Oracle has an own solution. I think it's called Golden Gate, right? Something similar.
Exactly right. And it's exactly that. So even if you use this library Xstream, you need to have a Golden Gate license.
Okay. This is what I knew. So, okay. And what about Microsoft SQL Server?
So we do have that. So there's a CDC feature coming with SQL Server, I think starting at the enterprise version, and this is what we are based on. And I mean, most folks in production have enterprise or even better, so then they can use that.
Okay, cool. So what it basically means, Debezium is Kafka dependent, so it's bases fully on Kafka, and the embedded solution is just wrapper around the Kafka connector, more or less, right?
Right. Exactly. So that's what we currently do. So, using the embedded mode, you can do different things. There's also, maybe you've heard about Apache Pulsar.
Yeah, exactly.
Which essentially is,
this is what I wanted to ask you, because getting more and more popular, and this is what...
Yeah, right. Exactly. And they have built-in Debezium support. So there's something similar to or comparable to Kafka Connect, which I think is called Pulsar.io, if I remember correctly. And they even bundle the Debezium connectors with Pulsar.io. So if you are on Pulsar, you can use it out of the box even. And then what we are also exploring, we think about having like a standalone service for Debezium. So essentially it would take the embedded mode and then this would run as its own runtime, so maybe based on Quarkus, and then it would be an own process, and then again there would be like an outbound plugin SPI, so then you could configure this service and you could say, okay, I would like this, to send changes to this REST endpoint or send changes to this kinesis topic and so on. So that's also something which we explore.
Yeah, actually, Quarkus would be perfect for that, right? Because,
Yeah, absolutely. So we definitely would base it on Quarkus. I'm not quite sure whether we could run it natively, at least initially, but even running on the JVM, it would have many advantages, and this would definitely be the perfect runtime. So we could use, all the APIs which exist there, right, for microprofile, for monitoring and metrics and so on. So this would be a very interesting approach.
Is there demand, or you're thinking about sync connectors from Debezium? Because if you read from Postgres, you can also write to Postgres on the other side, and you would have replications or data warehouse, data, transformation, stuff like that.
So, that's really the nice thing about Kafka Connect, that it is like this rich ecosystem of connectors, and there's pretty much a sync connector for everything. So there's HADBC sync connector, an Elasticsearch sync connector. So far we didn't see the need really to come up with sync connectors. I know some of the sync connectors, for instance, there's the MongoDB connector. They even support or have some support for Debezium's event format. So just to make this a bit easier to use. So the reason there is, well, in our case, we create this complex event structure, right? So this has like the old row state, the new row state, this metadata, this is, the database name and position in the log file and so on. And then many of the sync connectors, they are just interested in the current state of the data, which they should write to whatever system they support there, right? So let's say the JDBC sync connector, this one really just wants to have what is the new row state in our change events. And so we provide a message transformation for that. So that's another notion of Kafka Connect, which allows you to modify messages either before they are sent into Kafka or after they are taken out of Kafka. And now we have this one transformation there, which just takes this new row state from the Debezium change events and which would just propagate that one to the sync connector, so it can write the update or insert in the JDBC database. But this is another step you need to configure, right? So when you set up the sync connector, you need to set up this message transformation. And so, for instance, in case of MongoDB, this is not needed because, well, there's built-in support for Debezium change event format. So they know, okay, this is a Debezium event, so we know how to handle it.
Yeah, the sync connectors are actually very easy to write because you don't have to hook to a database. You could just just use your straight JDBC driver and just generate insert or updates, and you are golden basically.
Exactly. So this is not too hard to do.
Yeah, but there are almost no source connectors for database because it is a low level work, which with some effort to do it right, and therefore whereas Debezium shines, right?
Exactly right. So that's the idea. we do this tricky engineering and all the hard work, and then people can just use them and enable all those data pipelines.
Yeah. So now, so killer use case of the whole thing. So what we actually get with Debezium database and Kafka is a system where a database or database table is converted to a stream of events, which are persistent and consistent. It means the order of events is there. So this is of configuration, but we could do this because of Kafka. And
yes, this relates to the partition.
Partition,
right?
exactly. But, partition and consuming groups, but this is like Kafka thing, and nothing get lost usually. And
let's remove the usually. So we are very keen that no data ever gets lost. Otherwise, if it happens, it's like a super blocker bug, and we are looking into it right away.
Yeah, now let's take a look at that. So if I would write a embedded Kafka connector and I will die, would I be able to read the old event? So there's something like offset in Kafka, or this event?
Yeah. No, exactly. There's the notion of offset. So the way this works, so we send the change events to Kafka, and then regularly the offset, which essentially is the position in the source log we have read, this one is committed. So this means if the connector crashes and it gets restarted, it will get to read the last committed offset, and then we can continue to read the log from that position. So this has two implications. So the one is, this is always subject to at least once semantics, right? So it might be if a connector dies and it gets restarted, you, as a consumer, you would see certain change events another time. But usually that's fine. It's quite easy to deal with those duplicate events. So that's the one thing. And the other thing is, you need either to be careful to not discard any transaction logs on your primary database, as long as the connector is not running. So, right? So let's say your connector is not running because you are doing an update to a new Debezium version. You must make sure that the transaction logs are not removed during that time, right? So that when the connector gets restarted, the logs are still there. And then on the other hand, we also must make sure that we don't keep logs for too long. So for instance, in Postgres and the logical decoding there, we actively acknowledge the offsets we have consumed. So this then allows the database to remove those logs if they are not needed otherwise. But for instance, in the past, if there was like a bug and this acknowledgement didn't happen for some reason, well, then the transaction logs on the database would pile up, which of course is a problem, right? But then I think this is sorted out, so it doesn't happen anymore.
But is this also true if I would write my own embedded connector? So if embedded mode, I run in embedded mode. Then if I die, are the events lost because I forgot to read them, or what is the semantics there?
So in the embedded mode, you need to take care of the offset persistence yourself. So essentially, there's an SPI you need to implement for that. So in the simplest case, you would have like a file-based implementation of this contract, and then again, the embedded engine will call you using this contract and say, okay, this is the offset, please, however you do it, persist it. And then if you get restarted, well, we would read from this API, the latest offset, but you would have to take care of that. So I think most of the people, they use a file-based approach, but you could, again, think about something based on the database or etcd or whatever.
Right. So, and this is one offset per database, right? Because this is like global, or is this one offset per table? No, per database.
No, it's essentially, it's a global thing, which is scoped for the connector. So the database.
Yeah, and this is one number, or is this more information I have to store?
It depends on the specific connector, so that format is different. So, I don't know, let's say in Postgres, it's like the LSN number, the log sequence number. In SQL Server, it's forgot the exact name, to be honest. It's something different. In MySQL, maybe it's a GT ID and
similar
log
stuff.
file name. Right. Semantically, it's always the same concept. Yeah. It's a position in the log file. How it is structured, this is different. So you would get a map, essentially, with one or more properties which unambiguously describe this position.
That is actually great news. So what it means, I could write my own embedded connector and write the stuff, let's say, in database, because if I would write to flat file, there's the issue, if I'm running on Kubernetes or Docker, where to store the file, right?
Right.
So if there's a database, like let's see, four columns, I can write it. Then if I die, I just see what was the offset and just proceed with my reading.
Exactly.
And nothing gets lost. So this is actually a nice solution because it's simple and actually bulletproof.
Yeah, definitely.
And
right. I mean, that's the idea. I mean, for Kubernetes, I always was hoping maybe you could do it. Someone would explore how to use etcd and persist it there, because I feel that would be like a good use case. So that would be interesting to see.
Yeah, etcd or persistent volume or whatever you will have to do. But if in all my Java EE apps, we always have database, so I could just use a database. And
right.
And then I will see my own event, which does the backup, right?
Exactly. That's the thing. So you need to fill that one out.
No problem. So okay. So so this is actually incredible. So the first thing what we can do is you could, of course, the simplest possible thing is storage to Kafka, create a consumer group. Then you have a load balance, let's say Quarkus or Whitefly application servers or Java EE application servers. Every application server listens to the Kafka topic one-to-one, converts the thing to WebSockets. And the cool story is now we have, let's say, 5 WebSocket servers, and the client can choose one, because the event it is just read once, I would say, and then it's going to be published. And this would be like the simple possible, conversion, like notifications to clients for, like, let's say, how to call it, reactive or, interactive, interactive clients. This was the first one. And also interesting use case, what comes to mind is just using, Kafka streams, and then you can, react to insert updates, and with Kafka tables you can have aggregations in real time.
Absolutely,
right? So
right. So that's definitely something which I really think is a great combination. So CDC and then Kafka streams or DBs-ium and Kafka, this you together, this is really super powerful. Lets you do so many things. So, all the stuff which I mentioned, right, where we do this enrichment of the change events with the transaction scoped metadata from a different topic. So that's something you can easily do in Kafka streams. I did, so that's a demo I usually do in my talk. So the idea there is I have, let's say, e-commerce application, and there's a table with purchase orders, right? So new purchase orders come in, and now you're interested in let's say, in the revenue per category in some sort of time window, right? So again, that's something you can easily do in Kafka streams. So what's the revenue of the furniture category in the last hour? And this is what I show. And it's not too much code with Kafka streams. And then actually, I also stream the results of that to WebSockets clients, and then I have a little chart in the browser running, and the columns, they go up and down as the revenue of the different order categories changes.
Mm-hmm. Also, somehow interesting story, probably. I would say, probably, let's say, 10 years ago, probably, with Java 6 or Java 7. I was constantly asked, do you have any, like real world examples? And the problem with me is lots of NDAs, so it's really hard, to tell about clients. So what I did, I needed like a statistic system for my blog. So okay, I would like to see how often an article was read, because I had the impression that my blog is just too popular, and wanted to see what are the actual numbers. And I wrote back then a very simple system, which was a REST endpoint, and the blog engine reported the hits with the titles of the blog posts. And it was stored in a database, and this was, I think, Derby or H2. Derby, it was Derby, and then I created queries. And with the queries, I saw, how popular the stuff is. And to see, for instance, the 1 hour average and the most popular in 1 hour, 1 day, I had a scheduler. So 1 minute scheduler per minute, per hour, per day. And then I noticed, the problem is, I have lots of ideas about the queries. So I wanted to implement more and more queries, but I had to redeploy the whole system. So and then I look at that, and then I think it was Java 8 came out, or this was right after Java 8. And then I thought, okay, what I could do actually is the database is not really needed. It's just statistics. So I use Infinispan or Hazelcast. Mm-hmm. I think I use both just for fun. And there were like 2 nodes. So I wrote to one node, and it was replicated to the other one. I wrote to one node and then read from the other one. And and then the queries were basically Java 8 lambdas. So I had a CQRS architecture, because if I wrote to the first, Infinispan, this writing was always the same. I didn't have to change the system, at any time. And the reading stuff was replicated, so I had another instance where you can play with, because if it crashes, the query server is gone, but no one cares about that. The problem is, if my blog stops working, I got lots of emails, your blog does not work, which is a little bit annoying.
Yeah.
So it's somehow mission critical to me. So and the red part, so I play with that, and this is basically like it is right now. So and I, just for fun, I ported this to Quarkus, and it works fine. So it was a non-event. And now what I could do, and I probably will do just for fun. It works too good for 5 years or whatever. But let's imagine that. So what I can do right now is I will take the first part, right, the writing part, and convert all the HTTP events to Kafka events. So now I have a Kafka topic, and what I can do, I can, for instance, group or this called branch. So branch the topic according to blog post. So what happens on the other side? I get multiple topics per blog post, something like that. And then I could actually do whatever what you said right now. Use, for instance, K-tables to aggregate. I can have sliding window of 1 minute, so I will see the hits per minute, and then I will see a sliding window of 1 hour, 1 day. So everything, the functionality is the same, but the architecture completely different, and
absolutely,
and more flexible. And but if this were, let's say, an legacy project, I could do the same with Debezium. So let's say Debezium had support for the database, which in my case was Derby, which doesn't matter, but I couldn't convert it to Postgres. Then I could stick with the old solution, then convert the Postgres events to, let's say, Kafka events, and then can do the same with Kafka right now. This would also, converting from old architecture to a new one. Yeah,
absolutely, and that's a very common use case. So people have this legacy database, and they don't want to touch the application code which writes to that, but they are interested in the changes, what's happening there, and then they can set up the Debezium, and this really is transparent at the application level, right? So they don't need to change anything there, and then they could exactly do what you described. So by the way, have you seen that there's an extension for a Quarkus extension for Kafka Streams as well?
Yes. And it works perfect. So how it would work with Quarkus is there are basically two annotations: incoming and outgoing. Incoming and outgoing, right? Incoming and outgoing. So and very simple. You could have a method with two parameters. One parameter string in, and let's say double out. And then you say incoming is one topic and outcoming the other one, and you can do in the method whatever you like. And the data from one stream comes in, and then you can convert this to, let's say, you can convert the string to a number, and then do something, and then flows out. And the configuration happens with microprofile config, so you can configure So this is a really nice, I would say, no-code integration. So if you compare this with the origin Kafka, so you have to write a little bit more. And and you can even create topologies, do whatever you like. So I think this is very nice integration between Quarkus and
absolutely.
Kafka.
I mean, so that's the reactive messaging API you described, right? So this works with Kafka or AMQP and other things. And that's definitely great. But there's also an extension for Kafka Streams specifically. So you use the Kafka Streams API, and then you can all those things like joining topics and maybe interactive queries, stateful operations, which you cannot easily do with the other API. So there's support for that as well.
So this API you're mentioning, this is the one where you have produced the topology, right?
Exactly, right. So that's exactly where you produce a topology, a K-streams topology, and then you work with K-table, K-stream, and so on. And this also is supported. This works on Quarkus. So this works also in native mode, which was a bit tricky to do because there's a dependency RocksDB, which is used in Kafka Streams. And, so this all now works out of the box also on native code and GraalVM. So that's cool. And what we just recently added is a dev mode support. So I guess you have seen the dev mode in Quarkus where you just reload the page and it picks up your code changes there. So you can have this kind of live coding experience. Mm-hmm. And now this also is supported for Kafka streams. So what you can do there is you can keep a producer running. So this just feeds messages to your input topics. And then maybe you have a consumer for your output topic, and now your Kafka Streams application, it takes something from the input topics and it writes it to an output topic, right? And does some aggregation and mapping and so on. And now the dev mode support also is there, and that means you just change the code of your pipeline, you hit save, and then right away the pipeline will be reloaded. And when the next message arrives, essentially you will see, okay, now this is what the pipeline is doing now, and you can see it in the output topic. So this is really a nice way to get very quick feedback as you work on such a pipeline.
I think this happens recently, because before then I tried that in dev mode and it worked, but it didn't recognize the Kafka changes. So I have to kill this and restart, but the restart was like 1 second or 2 seconds, so doesn't matter.
Right. So this is something which we just, I think it was published 2 weeks ago or so for Kafka Streams. So it's not there yet in the reactive messaging API you described earlier, but it's supported now for Kafka Streams.
Another interesting use case for Kafka, for Debezium and Kafka is something like, how to call it, make Hibernate Inverse obsolete or a little bit simpler, because
absolutely, yeah.
What Hibernate Inverse is like historization of records. So you see the recent record and then the whole history what happened. And the problem with that is always the database itself, because for me, also correct me if I'm wrong, but for me the database is like, how to call it, like the materialized view of a Kafka stream. So like in Kafka you see, the whole history, and the database you see the recent state, the most recent state. And in some finance applications or other applications would like to have, the whole history and of the thing. And Hibernate Inverse, for instance, what it does is you have like multi-dimensional search, I would say. You can search for key and the version. So you can say, give me all versions for the key, or give me, all versions for the key, exactly. And you get a list back. But you need to know more tables in the database. And the problem is, the database grows because you have to store all the historical data as well. And in projects we had the problems that we would like to keep the operational data and historical data separate because of performance reasons. But for Kafka it's just natural, because Kafka is a stream of events, and with that you can you have the database as your recent state and Kafka as the historical data I can use for query the data afterwards. So this is what I will also see as an interesting use case.
Absolutely, definitely. I mean, so with any library-based approach, be it Inverse or anything, so definitely, it creates more data in the database. I think even more important to consider is that it creates just more inserts in your actual transactions, right? So it does not only write your actual data tables, but then it also needs to write the history entries. So this is just, there's an impact on the latency, right? And also, I mean, then there's some subtle issues. So for instance, if you use like a bulk delete or a criteria bulk update, let's say, then Inverse just wouldn't be aware of all the affected entities. So then it would miss out on those. So and this is something which wouldn't happen by definition with the log-based approach, right? So we get all the changes from the logs. So there's no way anything would be missed. Mm-hmm.
Perfect. So so just a broader topic, Kafka. So there, what's funny in my project is like people consider like it's like JMS is like way too complicated and is too enterprisey and is no legacy, and let's use Kafka for that. And the interesting story right now is, I don't know what your impression is, that the most developers confuse streaming with messaging. Because if you have JMS, this is a complete inverse to Kafka. So
absolutely,
with JMS you send a message, and you would expect the message, that it disappears immediately after it was consumed. So I have 2 microservices, so I can send a message to one microservice. Reliable messaging. This is like more and more SMS, right? And Kafka, for me, conceptually, is a database first. So this is like you could eliminate with Kafka most of the relational database in projects, actually, if you do it right. So
So I'm not so sure about that one, to be honest. I mean, the way I see it really is like it's a commit log, right? And then one very important part which is missing for database is query capabilities, right? So you want to query your data based on, well, certain criteria, and that's just not something you cannot do with Kafka itself, right? So you always need to have some sort of materialized view which you then can use for the query.
You could do it with K-tables. So there's intact, so there's like SQL-like query, but I think even this is not less and less needed, because if you think about this, what we had with my blog and with the statistics with Java 8 streams, and if you covered it this way, what's only is left over is a small portions for reporting, querying, or whatever. But I would say you could eliminate a large parts of the database. You can join
but
streams.
I mean, keep in mind also Kafka Streams actually uses a database underneath, right? So it uses RocksDB or whatever.
Yeah, but you don't see it.
You don't see it, but that's what I mean. Kafka itself, that's just one part of the story, I would say.
Yeah. No, but what really happened in my project? So we did it. So if you do it consequently, Kafka. So you can have Kafka is persistent, so you can it is replicated, and you can store lots of stuff in Kafka. And if you have Java 8 lambdas, let's say, then everything dissolves. So what remains is just you need some iterative queries, or you need you would like to fetch some data from the table. But at the end of the day, we have like a sync connector where it reads from one topic with data whatever like in a database, and then we have in the database. But the whole architecture changes. This is what I wanted to say with Kafka.
Yeah, absolutely. I mean, it opens up so many possibilities. What I would like very much is the aspect that the consumer is in charge of saying where would I like to read from, right? So that's different than what you had with the traditional broker. So you can reread an entire topic and so on. So I think this, that's just super flexible.
Yeah, but what you already did with the orders, right? So if you have one topic you are reading and converting the data and make some calculations and write to another topic, and then a microservice can read from this topic and has already the what you did purchase or the volume per category or whatever. And with a database, you will need a database with table and queries. So it nicely decouples the services, and it's persistent. Why I'm saying that? Because I got some requests. They would like to have Kafka, but without persistence, just as a nice replacement for JMS. I was like, okay, we could even try to have JMS without messages, just for fun, and see what happens.
Okay, interesting.
Yeah, interesting. So, what is on your roadmap with Debezium?
What's on your roadmap? So currently we are going to the 1.0 version. So that's an important milestone. What it essentially means is, so we are not planning to add too many features for that. What it more means is we are stabilizing the messaging format. We are stabilizing the structure of the configuration options and so on, because then we don't want to break, and also right now we don't want to break any consumers, right? But after the 1.0, we would be even more considerate to do that. So that's the one thing which happens next. Then in terms of connectors, so there will be a DB2 connector, as I mentioned. Then folks from the community are working on Cassandra support, so that's very interesting. I think we will definitely have this standalone mode, which I was mentioning, so that you would have your own Debezium service. There's we didn't talk about it actually. There's this outbox pattern, so we want to have better support for that. So the idea there is, if you capture changes from your actual tables, so let's say your purchase order table, and then you stream those change events into Kafka or whatever, it kind of exposes the internal structure of your data model, right? And maybe depending on use case, that's something which you don't feel like you want to do it because the data is consumed by another team, and maybe you just don't want to expose the internal table structure. And this is where this outbox pattern comes in. So the idea there is the writing application, it not only updates its own business tables, but then it also creates a message structure. So let's say a JSON structure or something like that. And it writes this one into a dedicated table. So the outbox table. And this is done as part of the same transaction. And then Debezium is used to capture the changes just from this outbox table and send the events from this outbox table to Kafka topics. And there's already some support for that. Now you have different event types within this outbox table, right? So there might be a customer event, a purchase order event, and so on. So we already have a routing component which then takes the different event types and can send them towards different Kafka topics. But we want to grow the support for this pattern because this is something which, got some good traction in the community and people are very interested in using this. So for instance, we are thinking about having a Quarkus component, right? Because you also have to have the application side part of this pattern. So you need to have some component which actually does the insert into the outbox table, right? And this could, for instance, be based on CDI events again. So your application would just have to fire a CDI event, and then this Quarkus extension could take care of writing to the outbox table and so on. So that's something we want to do. Many other things really. So we think about having some things around transactional grouping. So this comes again to this matter, comes back to this matter of ordering, right? So you have different change events, and as long as they are within one partition, you have the ordering guaranteed, but this doesn't apply if it goes beyond partitions or even beyond single topics. So we are thinking about publishing a specific topic which just contains like some transaction markers. So, okay, this is a transaction which has started, here a transaction has ended, and maybe it has touched those other tables. And then this should allow a consumer to correlate the events from run transaction. So that's also an important thing we want to explore.
Yeah, this is really useful because otherwise if you have multiple partitions, you don't have the order. With that, you could reconstruct the order if there is demand. Right?
Exactly. That requirement comes up every now and then. I mean, so usually you are fine with just having the order for a specific record, and this is actually guaranteed because we send all the records for the same purchase order or for the same customer. They will all go into the same partition. So if you look at your customer 123, you will see the change events for this particular customer in the right order. But then if you have change events from multiple customers and they go into different partitions, then, the ordering wouldn't be guaranteed. And sometimes this requirement comes up, and there's definitely cases where you need it. So we want to support that definitely probably by exposing this kind of transaction topic, which then would let you reconstruct the ordering.
Okay. Nice. And will be the ever support for the Debezium from Red Hat? Would it be possible to buy it?
Absolutely, yeah. So this is also something which has been started already. So currently there's a developer preview. So this is really the first level of being a product at Red Hat. So you can come and you can try it out and you can give feedback and get in touch with the solution architects and so on. The next step will be to have a tech preview for that, a technology preview. So this is the next level. There's then support for this in place already. And we are looking to have some of the connectors as GA, so generally available early next year. But that said, it's all, forward-looking statements. So it might change.
Yeah, this is the huge slides with lots of legal stuff on it, right? This is the safe harbor statement.
Exactly.
Right?
So that's what I just gave you. Right?
Yeah. So imagine the
but
slide.
So this is happening. I mean.
Yeah.
Really, there was. We used to be just a community project, right? And I mean, of course, we wanted to have a product, and really, people very often came and hey, we would like to have support. And now, this is actually happening, so this is a great step.
Support is very important. So some of my clients would just run software which is supported, regardless how good the community is. I think that's also very important for a open source product, and we are talking about databases and persistent data. So where you can get optional support from a vendor behind the solution. Yeah.
Absolutely right. So I think that's why we are going to the 1.0 version and, being sure that the contracts are right and all this stuff is happening. We took we took the time in the community to really bake it, and we got so much really useful feedback. People are using it on large installations. So I know of people, just recently somebody opened an issue and said, we got a couple of hundred connectors running, and now we have this particular issue. So what can we do? to. So people are really validating this with huge installations. I know there's another company, they have like thousands of MySQL databases and they stream changes out of those with Debezium. And I mean, that's really very valuable feedback to have. And we could improve the connectors. We could fix tons of bugs. And now we feel, okay, it's at the time where we can, actually offer support for that.
So perfect. So, would you like to mention anything or?
No, I think we discussed all the interesting bits. I would share a few links with you if you wanted to. You can add them to the show notes.
Absolutely, do it. And where people can find you? So Debezium is Debezium.io, right?
Right. So that's the web page. We just redid it. Like there's now also much better documentation for different releases and so on. And then there's also all the links are there. There's a Google group. We have a chat room where people can ask questions. But really, the Google group is the best place, I would say, to get help and come up with questions. Also, if people are looking for something to work on, this also always is nice to see, right? So we have issues in Jira labeled with the easy starter label. So if people look for something to hack on, they can do this. And this actually is really something I'm very happy and excited about to see. So, I mean, it's a Red Hat sponsored effort, but really it's a huge community which is working on that. So by now we have, I think, almost 130 folks who have contributed to that. Some do just a small fix and then that's fine. But then others, they really stick around and do longer work for a longer period of time. The Cassandra connector, this is led by folks from the Debezium community. So this is really the thing I'm so excited about to see that it's not just the small team I work in, but it's really like a wider community and many people are working on this together.
One interesting feature I thought about that was about if you are running something in Quarkus. Let's say you decide to run the connector in Quarkus. You could emit some Prometheus metrics, for instance. Could be interesting to know what happens behind the scenes, or how many events are processed and whatever happens. So
yes, absolutely, definitely. So currently we have JMX support, so you can connect with Visual VM or whatever, and then you would see the JMX metrics. Now JMX doesn't work in Graal VM native mode, right? So if you were to use the connector in that kind of setup, then having something around, let's say, microprofile metrics.
Exactly.
So you can consume it with Prometheus. That would be definitely awesome. Yeah.
Perfect. So, and what's your Twitter handle? You remember this?
My personal one is Gunnar Morling, @GunnarMorling, and then there's also @Debezium. So you should follow both.
So thank you, and we should talk, next year about new use cases and new features, if you like.
Absolutely. Yeah, always a pleasure for me to be here. Thank you so much for having me.
So thank you. Bye.
Bye-bye. Thanks.